Okay, number 8. Forensic scientists often examine scaled-up crime scene photos to search for evidence that might be hard to identify at regular size. Studying bite marks on a photo of a victim leg at 500% magnification, that means it's 5 times as big as the actual size. A technician measures the distance between 2 punctures from a bite to be 165 millimeters. What is the actual distance between the punctures? So again, the ratio of the photo size to actual size, they said the ratio of the photo size to actual size is 5:1. Let's go and use a proportion for this one. So the photo size was this 165 millimeters. So we're going to put that in the numerator, because remember that was 5 times as big as the actual size. Right, let's take a cross product. 5x equals 165. So x equals 33. So that means it would be 33 millimeters. That would be the actual distance between the 2 punctures. All right, more on scale. Here's a look at a map at the east side of Dubuque, Iowa. Shows a driving path from the casino on the river to a golf course on the other side. According to the Maps app on his phone, the driving distance is 3 miles. We're most interested in the graphic at the bottom left. Okay, and this is what they're talking about right here. All right, which indicates that 1 inch on the map corresponds to 2,000 feet in real life. So number 9 asks you to write a ratio that compares size on the map to the size in real life. So they're saying that 1 inch is equivalent to 2,000 feet. Next it says points A and B on the map are 4 and 600 inches apart. How far apart are the casino and golf courses in miles? They say use a proportion to decide. So 1 inch over 2,000 feet. And they're giving us the points on the map, 4 and 600 inches apart. So where should that go? Well, hopefully you're saying that should go up in the numerator. Okay, so let's make that happen. All right, so pause the video and work this out on your own. Okay, so we got 8,020 feet. And then remember they wanted it in miles, so we can do that because we know how to do a dimensional analysis. So 8,120 feet, there are 5,280 feet in 1 mile. So 8,120 divided by 5,280 is approximately 1 5400 miles. Now 11 asks us to write an equation of variation that relates the distance on the map, m, to the distance in real life. Then use information you know to solve for the constant of variation and update your equation. So I'm not really sure this is a wonderfully written question here. Let's just go with the distance on the map varies directly as the distance in real life and go from there. Okay, so on the map we know that 1 inch is equivalent to 2,000 feet. Okay, and then solving for k, our constant of variation. I'm going to go ahead and leave this as a fraction for now. I get 1 over 2,000. So let's rewrite our equation with 1 over 2,000. It's our constant of variation. All right, and I think we're good for number 11. So number 12 says, if we looked at a satellite photo at the same scale at this map, do you think we would see any boats on the river? Well, I think it would be very difficult to see. It might be like a little speck or something. And so 13 helps us give reasoning to that. It says, let's say that a 50-foot boat was out in the river. The typical recreational motorboat is about 18 to 20-foot range, so a 50-foot boat's pretty big. Use your variation equation to find how big the boat would be on the satellite photo. So let's go and use our equation. Remember, it was a 50-foot boat. And that's going to turn out to be 25 thousandths of an inch. So again, it's going to look more like a tiny speck than a boat.